Okay, we're going to get started right now. Welcome to everybody who's here live, and I'm glad for all of you who are watching this on the video, the recording that we'll put on YouTube. So I just want to make everybody make sure that you all know of the fun things that we're doing. We have a lot of great things happening. We have the YouTube channel with cool content on it. We've got our free Zoom meeting every week. That's what we're doing right now. I have my Patreon page that has over 300 content videos and articles. And I've got my 17-week career farmer training. I don't even know what to call that, but it's pretty awesome. We just had our graduates graduate a couple of weeks ago from our first year. It was a raving success, and we want more people to sign up for that next year. I'm a soil laboratory. I can tell you what critters are in your soil so that you can be happy and healthy when you get your soils running good. So that'll be pretty great. What else? I do consulting. If you're wanting to start a farm, I can do consulting for you. See if I can run my computer here. All right, so tonight we're going to be talking about ecological succession. We've covered this before, but I keep getting lots of super fun like questions, I guess, conversations about ecological succession and the ecological processes. So we're going to review the ecological processes tonight, and then we're going to clarify things about succession. So we're just going to do this fast, and then we will take some questions. And of course, during the question time, you can ask me questions about anything to do with food production. I guess you can ask me questions about other stuff too, but I probably don't know the answer. Okay, so the 4 ecological processes. We have to have these processes working in order to maximize production in whatever we're doing. If these 4 ecological processes don't work, it really matters to a lot of human life. I think it matters pretty much to 100% of human life. But if you're in manufacturing, if you're in whatever, these processes matter because everything in human life comes first from the sun, which is the energy flow. The sun gives us all life on earth. Everything that has to do with food and clothing and housing and warmth comes from plants. We have to have good plant growth on this planet. So we need that energy flow to happen so that plants can make food for all other living organisms. And that leads us to the mineral cycle, because the plants can't grow if the mineral cycle is not working. So we've got our energy flow from the sun that powers photosynthesis, but plants also have to get fun things like molybdenum and iron and zinc and copper and all 40 however many there are of all the minerals that plants use. And I think in the future, we will discover more minerals that plants use. Just recently, we've seen how sodium is used in plants. In the old literature, they say salt is a nutrient for animals, but plants don't need it. Well, recently we've discovered that plants do use sodium, and there may still be scientists arguing that, which is a fascinating thing. But we are learning more. Every decade that goes by, we learn more about what the mineral cycle does for plants and animals. But we need to make sure that our mineral cycle is working. And the way that it works the best is, we can see that in examples. If we go to Mother Nature and we look at ecosystems that are thriving really well. I always love to use the redwood example because it's a massive, massive amount of organisms. If we take 1 acre of land, so 208 feet by 208 feet, and we count how many calories are being created on that acre of land. Most people don't think of it in terms of calories, But farmers think in calories. We think, how many calories can I produce on a 1 square foot? If you remember old Mel Bartholomew and his square foot gardening, on 1 square foot, I can create a certain amount of food. On 1 acre, I can create a certain amount of food. On a hectare, or on 1,000 acres, or 1,000,000 acres, how much food can I create? And when we translate food into human energy, we talk about calories. So how many calories can be made? But it's pretty awesome, because when we look at the mineral cycle, if our mineral cycle is broken, then we have to help plants grow without mineralization happening naturally. See, in the redwoods, it happens naturally, a very high functioning mineral cycle there. It's working good. And you don't have people out there putting fertilizer out. But in a farming situation, we put out fertilizer if the mineral cycle is broken. And we have found that that becomes an ecological problem, because the more we use fertilizer, the more dependent we are upon it. Let's move on to the water cycle. The water cycle is broken in many parts of the world right now. So what are we doing to compensate for that? Well, in a lot of the world, communities simply dry up and people move. And where do they go? If they can't grow food on their land, I want you to think Africa right now. One of the biggest deserts, I think the biggest desert in the world, is the Sahara. So there it is in Africa. And when the desert sands advance, they're blowing, they're advancing, and no rain falls. The water cycle's broken. The families simply have to go somewhere else. It causes social problems. It causes economic problems. It causes societal tension. It causes political issues. There's all these issues that happen because the water cycle is broken. And I used to hate it when politicians would say, in fact, I do still hate it when politicians say this, but I like it when ecologists say it, because we have answers. But politicians used to say, and they probably still do, that, oh, the environment, it's broken and we need to fix it. That used to bother me because they never had a solution, and they still don't. But when ecologists, a good ecologist, because all ecologists are not created equal, but you get a really smart ecologist and they say the water cycle is broken, humans have a big impact on that. And that's another thing that politicians say that's frustrating, is that the human is causing the problems. We hear that from people. You hear it in the media. There's a lot of documentaries who say that the human is the problem. But a good ecologist will say the human is the one organism that can understand all of this, and we can fix the water cycle. The human can fix the mineral cycle. The human can maximize the amount of energy that is coming from the sun by growing a really big plethora of plants on that 1 square foot. So we can have a great positive impact on the water cycle, the mineral cycle, and the energy flow. So I'm going to switch my slide and we're going to talk more about ecological succession. But before I do, just look at this real quick. And you can see the early succession is where new ground is formed. Mountains are formed. Volcanoes create new ground. So that would be primary succession. Secondary succession would be when there's a catastrophe that takes land that is producing, it could be in mid or late succession, and it creates bare ground. And so it throws it back into early succession. So there's primary succession, which is when you form new ground. Secondary succession is when you create bare ground on what was productive ground. So ground that becomes desertified would be secondary early succession. Or a forest fire would be secondary early succession. Or a landslide, or there could be other things, floods, other natural disasters, a meteor hitting could create early succession. But generally, early succession that we deal with in a real practical sense is desertification. And we create desert, this secondary early succession happening. It's pretty widespread, and humans do create that. And I'm not saying that to condemn anyone. It's simply something that we have done with our management over thousands of years. And I can go out here, and certain things that I do could create a desert within a decade with really bad, poor management. But I can also turn it around. I can turn it around in a decade. I can turn it around in maybe 5 years. If I'm lucky and Mother Nature is happy with what I'm doing, you can turn it around in 20 seconds by putting an inoculant on the ground, get the right microbes in there, and those microbes are going to make the mineral cycle work, which makes plants grow. And then if I plant a lot of plants, it'll maximize the energy flow. And then that will create the aggregates in the soil to soak up water. And so when it rains, I receive 100% of the rain that came. And so my plants can grow like crazy instead of a lot of the water running off the soil that would cause floods and other problems that happens in a broken water cycle. Because when the water runs off, it doesn't soak in. So a week later, you're still praying for rain. And I love praying for rain. Don't get me wrong. We absolutely need to be praying to the heavens daily, maybe minutely, all the time. Continual prayers are great. But let's build a barn to receive the harvest that comes in the blessing that we pray for. And that's by creating the soil aggregates in the soil so that when we get a quarter of an inch of rain, we get it all. I have seen floods happen in a quarter of an inch rain, which is insane because a quarter of an inch rain isn't very much. But in broken water cycles on very desertified land, that can happen. Let's move on. Okay, so ecological succession. What is ecological succession? So I put down three things here, three terms: ecological succession, community dynamics, and climax communities. In the old literature, years and years ago, scientists would write about climax communities. And what they meant by a climax community is that an ecosystem has reached a place where it is stable. And so you may have, let's just go back to the redwoods. The redwoods are a climax community. They've been that way for thousands of years. And it probably unchanged for thousands of years. Nobody was around 1,500 years ago. I mean, they were, but not to write down and take pictures so that we know if it has changed a lot. But from the best we can tell, the redwoods have not changed a lot in the last thousands of years. Let's think about jungles. Have they changed over thousands of years? Let's think about Hawaii. I'm sure there are climax communities of jungle in Hawaii that has not changed for thousands of years. And there's many places where we have these climax communities. So depending on what you're studying and where you're reading, if you go back 100 years, 200 years, and you're reading the scientists and learning the ecology, which is the best way to learn ecology, by the way. We have to have a broad education and a deep education. We can't just read one author and say, ooh, yeah, this is cool. We need to read a lot so that we have a clear understanding of what's happening. And so when we talk about ecological succession today, that's what they were talking about if you go back 100, 200 years and you're reading ecologists and they're saying climax community. So climax community can mean the same thing depending on who you're reading. But today I use the word climax community in a little bit different way, and we're not even going to go into that tonight. It's too complicated. That's for another class. But a lot of your modern authors today, or webinars that we're participating in, they will use the ecological succession, that term, and the term community dynamics interchangeably. But they're really not the same thing. But I just barely got done teaching my 17-week class, and I told my students these are the same thing. But I do want to clarify, they are the same thing to a point. It's kind of like mathematics is simple to a point. You know, you have adding, subtracting, division, and multiplication. If you understand those things, you can become a lawyer and have a great career as a lawyer throughout your life, because you don't really have advanced math classes. But if you're going to go into psychological statistics and do tons of research for the next 40 years of your life, there are other math that you have to comprehend and you have to figure that out. So, you know, to a point, ecological succession and community dynamics are the same. And with my math analogy I just used, when we start going deeper into the ecology, they can be used to define different things. So we're going to talk about that a little bit tonight. Community complexity is vital. So what is the community when we're talking about ecological succession? We're talking about the entire community of all of the organisms that are living in an ecosystem. So if you want to know something about your particular ecosystem, let's bring it down to the gardening level. If you walk out into your greenhouse or into your garden and you want to get rid of pests and diseases and weeds, it's important that you understand this because these are the fundamentals. And we are going into deep information here, but if we can go deep, if we have permission to learn a little bit here, then it makes our gardening so much easier and it makes our food so much healthier. It makes it so much more like flavorful and nutritious. It's fun to eat fruits and vegetables when they taste good. So when we walk into our greenhouse and we can simply count and we can say how many species are in here. And it's fun to count and it's fun to see. And if we have, you know, a lot, that's good. If we don't have very many, it's not good. So what if we're just growing a monocrop? You'll find it harder to sustain life. You're, you know, over the decades of growing your garden and you're doing patches of monocrops. I'm going to put my tomatoes over here and my corn over there. You're monocropping that when you think that way. And when you do that, you're going to find that over the long run, you're going to have to start using pesticides and herbicides and fertilizers and all these different types of things because all of 4 of your ecosystem processes are not working because you don't truly understand ecological succession, the community dynamics, and what climax community you want inside of your greenhouse or any environment that you're growing in. But you need to remember, the more species you're growing, the better. And I say to a point here, because if you say, well, if it's more the better, then I'm going to fill up my 1 acre with 1 million species. Well, you won't have room to grow any food if you do that. So if you had 50 or 60 species growing in a garden bed, that's going to be great. But 500 or 600 is probably way too many. So do we want to be in early succession, mid succession, or late succession? I used to ask my students this all the time. And the answer is, and if you're on this call tonight, you better be answering right now and saying it depends on your context, because that is the correct answer. So if you want to be growing early succession plants, you need to know what succession you're in. If you're growing late succession or mid succession, you need to know what you're in. So we're going to talk about that right now. So do you have low or high numbers of a plant species? So you're walking out to your food producing land, whether it's a square foot garden or whether it's thousands of acres. Do you have low or high numbers of species? So you need to count your species. Do you have 5 varieties? 5 species, or do you have 35? You need to compare. Do you have a lot of annuals or do you have a lot of perennials? Which is which? If they're all annuals, you're probably in early succession. If they're all perennials, you have probably passed early succession and you're in mid or late, probably. Do you have specific indicator species out there? Because there are some species that will only grow in an early succession or late succession. So it's nice to know some of your species. What are the age range of your trees and your shrubs and other perennials? Do you have a good age range of brand new ones that are sprouting in the last few years? Do you have mid-aged plants, and you have mature plants of one species. What about your woody plants? This one's complicated because whether or not you live in a brittle environment, brittle means you have a cold season that's a wet season, and then you have a dry season. So the Western United States is a brittle environment, most of it. Like the Willamette Valley would not be of Oregon. There's a lot of the coastal parts of California, Oregon, Washington. Those are not brittle. But most of the majority of the Western United States is brittle. But a non-brittle environment would be the Eastern United States. If you're living in North Carolina, South Carolina, Virginia, that is not a brittle environment. It's a little bit brittle. It's not it's not like a jungle on the equator, but it is very much less brittle. So woody plant species are complicated. If you live on the east coast of the United States and you have woody plants, that says you're in late succession. But here's the complicated part. If you live in Nevada, Utah, Arizona, and you have a lot of woody plant species, it can mean that you are one step away from desertification. So the widespread sagebrush all over the Western United States is showing signs of desertification because it used to be a grassland, and the grasslands are dying out, and the woody species are beginning to grow and taking over. So that means that they are in an earlier succession. How covered is your ground compared to bare ground? When you walk out, can you see lots of bare ground? Or is it mostly covered with living and dead plant material? This is very important to know what succession you're in. Because if you have bare ground, lots of dirt everywhere, you're in very, very early succession. What about the remnants of later succession plants? Do you go out there in your field and you see trees, but the only species or the only age of the trees are old? The only living trees are very old, and there's a lot of dead trees that died decades and decades ago, and no young trees have sprouted for 75 years. That means that that the land had the potential to be mid to late succession because it was growing a forest at one time, but now you're seeing those remnants of a different succession that is no longer there. So your succession is going from late to early. It means it's desertifying, which is a bad thing because desertifying land cannot sustain life, animal life, plant life, or human life. And the last one is an economic shift. So if I used to be able to graze cattle because I had tall plants that cattle could graze, but for the last decade I only have very short grass, and only the goats and sheep can live on that land. This is a sign of desertification because the economic shift of what the land will support has shifted. Now, if I used to only be able to graze sheep and goats, but now the land is conducive to grazing cattle because I'm growing taller forage, that means I'm doing the opposite of desertification, and I am becoming more I'm getting to those mid-succession places where the perennials are starting to grow. I'm getting the taller species, which is a very good thing. Okay, so this is kind of a deep overview. We certainly did not go into detail, but this was an overview of clarifying ecological succession and community dynamics over the last maybe 6 months. I've had good conversations with people, and quite a few questions have come up about this. I'm going to stop my screen share, and I'm going to turn this on here. Okay, I'm going to turn this over to questions. So go ahead and ask me your questions. You can ask clarifying questions about our discussion tonight about the 4 ecosystem processes with our focus on a little bit of depth into community dynamics, or you can ask me your personal questions about your own food production or.
So we have a question about indicator species.
Okay,
are wild sunflowers considered an indicator species of sorts?
maybe. What do you think?
Well, we have them growing all over in our garden this year.
Okay. Okay, so here's the question. Here's what you just told. Here's the information I have. Wild sunflowers coming up in your garden this year. Does that mean that this is something new that hasn't happened before?
No, they were there last year too.
Okay, what about a decade ago?
No, they weren't there then.
Okay, so what you're seeing is a shift. There's some kind of an ecological shift in something, and maybe it isn't. It probably is a community dynamic thing, because something in those plant communities has shifted and changed, and it's growing. Now, where do we see wild sunflowers growing in nature where people don't do anything?
Side of the road.
Well, yeah, on the side of the road sometimes.
Okay, on the side of the road. So the side of the road usually is bare ground, which shows a sign of desertification, but usually disturbed ground, because how long has the road been there? Has the road been there for 1,000 years? How is it being maintained by any kind of maintenance? Do humans mow? Are they mowing every year? Are they spraying? Yeah, and the answer is yes. Municipalities do that along the sides of roads and highways. So they keep it in a very early succession state, because they're not out there planting multiple species. Because in late succession, you find multiple species, like 20, 30, 100 different species growing together in the community. But with a roadside, it's being mowed down, or it's being sprayed with herbicides to keep the plants from growing, so that we can maintain a road and not have accidents. That way you can see a deer that's standing right by the side of the road and slow down. And there's other things like fires. There's other reasons why we mow roads. But my point is, it keeps it in that early succession state, because it keeps the ground bare, and it keeps the plant species low, the number of species low. So that would tell us that if a plant does grow there, then it's naturally going to be an early succession plant.
Right. Okay.
So does that mean that
We
your
need to
garden?
inoculate our garden, huh?
Yeah,
I gotta make a compost.
that's right.
Well, and I noticed one other thing. Our neighbors across the street hadn't watered much at all through the early part of the year, and most of the grass had died. And I took some drip tape over and set it up on their grass, and just with a couple of overnight sessions of watering, the grass came back. And when it rained this last week, those areas greened up faster where the drip tape had been. And the rest of the grass where they hadn't moved the drip tape yet was still really struggling to take advantage of the rain that happened. So I'm wondering if the way we water the ground actually helps change the water cycle, or or kickstart it or something.
It certainly does. Okay, so if you sprinkle, no, this doesn't necessarily have anything to do with your example you just told me, but it does answer the question of the way we water. Does it make a difference on the ecosystem? And I think it certainly does, because when a raindrop comes down, it's coming pretty hard. And when it hits, if it hits bare ground, it splatters and it will compact it. There's been quite a few scientific researchers show and publish that rain will compact the ground. That's why when we have a tillage system and we get a heavy rainfall right after we've planted corn, the top of the ground will crust up, and we call that capping in the ground caps. That's what it's called in ecology. And the corn won't come up. So they have implements that are called busters, and they'll go out and they'll drive that over the cornfield, and it will break up that crust, but not hurt the corn. The same thing with a sprinkler. When we sprinkle the ground, depending on the type of sprinkler, if you have a great big drop of water that comes down and splats, it can do a similar thing. If we have a fine mist of a sprinkler that's coming down and it shatters the waters into just mist instead of a big drop, then it comes down gently and it hits the ground, and it doesn't do that same compaction to the same degree, but it still can compact it. So dripping the water in with a slow flow drip tape is probably the very best ecological way to irrigate. The best ecological way is to not irrigate at all, but in our dry environments, we often need to. I think if we had a really good, if our water cycle was restored really well, we can grow a lot of crops without. But we like to grow crops that don't grow in arid climates, like tomatoes, and peppers. Those are tropicals, and so they need a lot more water than you're going to get in the Great Basin Desert and other places. You can't go 6 and 8 weeks, even with a really good water cycle working with those plants. Maybe you can, and I would love to see that. And as more people are doing this, somebody's going to prove me wrong, and I'm going to say, hallelujah, this is the best thing ever, because that's the point we want to get to for sure. I don't think you could do it in a traditional gardening way, though. It would probably be more of a permaculture way, where you have a food forest. So you have all your 7 layers of canopy and everything working together. That's probably where it would work in arid climates.
Okay. Very interesting discussion. Thank you.
Oh yeah, it's good stuff. All right. Any more questions tonight?
I have a question.
All right, Ezekiel, go ahead.
So, are all trees a sign of progression? I'm in the Great Basin. I know that sometimes woody stuff can be a sign of going backwards, but if they're actual leaf-bearing deciduous trees, are they a sign of going forward or backward, generally?
Okay, generally, I'm glad you said generally. That makes it very easy for me to answer. And the answer is yes. If you want general answers, I can do that. Yes. Now, we have to think this through. If you had, so I think mesquite trees. I don't know the answer to this. I'm just trying to think. But I know that on Alejandro's ranch in the Chihuahuan Desert in Mexico, he has mesquite trees that are dying out when his grass gets established. What does that mean? That tells us that mesquite are an early succession plant, because you can go out there and find vast areas of bare ground with scattered mesquite trees growing. So that really makes me feel like it's going to be a pioneer species. And a pioneer species is a species that comes in. It's a plant that can get established first on desert ground, and then it helps to nurture the other plants around it. So Brian just put a great thing here in the chat saying Russian olive trees are pioneer species, and that's true. Russian olives, I've never seen an example of a Russian olive dying out when you get a really good pioneer, or you get a good mid-succession climax community going. But hope people watching this recording if you have ever seen that happen, I want to know about it. And I want pictures too, so, but I have seen the mesquite die out once your grassland is going. And they are a tree. They're certainly a tree. They're not a giant big tree, but they are a tree. They're a mid-sized tree. They would be a, they're not that big giant canopy, but they would be a mid-sized tree, like the size of a fruit tree. And that's the same as a Russian olive. They're kind of a mid-sized tree. Okay, any more questions or discussion points? Any questions from the East Coast? We've got Vernie on
Oh, I
tonight.
don't have any questions. I just like listening to y'all.
Thank you.
Oh, I do have one question. I'm going to a nursery tomorrow that has elderberry bushes, and she ships to Nevada, so I'm thinking about getting some because we have not had luck in rooting those. I say we with a lot of generalizing. I haven't done anything to start elderberry plants. but you've been struggling with those cuttings that Amber had. And I'm wondering if these, coming from such a completely different climate, are going to be something that we can make work. I mean, I figured we would try them in the greenhouse and it'd be worth the effort because they're so good, but just wanted to know your thoughts on that.
Okay, 3 big problems with your thoughts on that. Oh dear, I've got to be nice to this person. Problem number 1, you said you haven't done anything. There's a book for you called When Queens Ride By. You've certainly done a lot. Problem number 2, yeah, there are problems with plants that are growing, being propagated in the East Coast, non-brittle environment, bringing them to a brittle environment, a desertifying brittle environment. Problems with that. Problem number 3 is there is no more important and expensive real estate than under the roof of a greenhouse. And so berries in a greenhouse is not a good use of space. Unless it's my greenhouse and I'm doing all these scientific experiments. I don't know. But elderberries grow here naturally and native. There are elderberry patches in the mountains right here where we live. We just have to get above the sagebrush line a little bit. But see, Amber's up there. They're at the same elevation as we are right here. And they're just growing. They have nativized, how do you say that? They're growing native. In that area, over the hill and you just get over these East Humboldts over the hill, and they're all over the place, and they're just growing wild in the rocks. So that's pretty awesome. So would it be a good idea to import them from the East Coast? It wouldn't be a bad idea. I don't know that it would be a great idea though. The thing to do is to go to some of these native ones, dig up the little tiny plants that are around them during the dormant season, meaning when the leaves are off, and because that's the best time to move trees. Very hard to move trees and get them to live when they're leafed out in the growing season. They simply don't want to stay alive if you move them. Okay, another question. Anything else tonight?
I have a question about growing fruit trees.
Okay.
Should you plant fruit trees and then attempt to bring your succession up around them, or do you need to wait until you have a higher succession to plant a large amount of fruit trees? I'm talking not like 1 or 2 in a backyard, but an acre or more.
Okay, so absolute excellent question. You've got to remember what succession actually is. Succession is not the indicator plants that we look at to guess what succession the ecosystem is in. Meaning, if I walk into a forest, it's pretty obvious that it's late succession, but not necessarily. If I walk into an old growth forest and there are no new plants growing, there could have been some kind of an ecological event that killed the microbes in the ground, and those are actually remnants that are going to die out, and we are moving backwards in succession towards bare ground. But it could take Mother Nature 100 or even 200 years, or anyway, a long time to do it. So the real definition of succession are the microbes in the soil and what ratio you have of bacteria to fungus in the soil. So let me say this again in another way. The definition of your succession is your bacterial to fungal ratio. Let me explain. Let me say that in a third way. The definition of your succession is late succession has a lot of fungus and less bacteria. Early succession has a lot of bacteria and not very much fungus in the soil. So let me answer your question. If you wanted to plant an acre of fruit trees, you would want to prepare your soil first by making a great biocomplete compost. And you could do it either the Elaine Ingham way or the Dr. David Johnson way, either way. And then you would inoculate your soil and you would start growing plants on that soil at the same time, because living plants need to be growing to continually feed your microbes. And then you would get species of like a multiple species mix of plants growing in there. You would want 30, 50 different species growing in there to feed a large microbial group in the ground. And then you re-inoculate 4 or 5 times throughout the growing season as needed. And how do you know? Well, you need a soil lab to be looking at your soil to make sure that your fungal to bacterial ratios are remaining where you want them. And if they're not where you want them, you need to work with that consultant and that soil lab to adjust those soils to where your fruit trees are supposed to be, so that your bacterial to fungal ratio is right. And you need your higher predators creating ammonium instead of so much nitrate, because that's another part of it, a part of the whole equation. And that can be done. It's easy to do because you need your protozoa group, you need your nematode group. You need to make sure that they're there so that it's working. Your whole thing is working. Okay. Your whole soil food web needs to be there. Okay. So there's 5 major groups that you need, plus some others. But your microbes are your bacteria, fungus, protozoa, nematodes, microarthropods. And then your not microscopic ones are going to be micro or macroarthropods, enchytraeids, earthworms, and then all your other creepy crawlies. You want as many insects as possible, as many bugs as you can get, including the pest species. And people go crazy when I say that. They can't handle it and they can't understand it. But the more life we have, the better off we're going to be. That was a very complicated answer. I hope that answered your question, Ezekiel. So yes, fix your soil first and then plant your trees. Don't plant your trees and have them starving to death. But could you do it in the same year? Maybe. I would probably want to start conditioning my soil for 2 years and then plant the trees. That would probably be the best way to do it. Create your climax community first with multiple species of things, and then get your fruit trees in once looks like it's stabilized. Okay, any more questions? You can unmute yourself and ask. You can type it in.
And I have one more question, but I don't know if we have time to answer it. So maybe this is a topic for another day. But why aren't more people talking about this? Because it provides actual solutions to some of the world's most serious problems. But it seems like it's just there's only like 2 big organizations I can think of that do anything with it. The Savory group and such, but they don't have a lot of political press. So I don't know. I'm just curious in your thoughts on that.
Yeah, that is a problem. Boy, I could scream about this for hours. The reason people don't talk about it is Alan Savory says it's because it's a wicked problem, and not like moral, or not the word wicked. It has a lot of different definitions, but a wicked problem is a problem that it cannot easily solve. It's like when you have an organization of people, because you're asking me, why aren't tons of people doing this? Because it's a practical solution. Yeah, it's a practical solution, but the paradigms of people today, the majority of people, the masses of people believe if I have a problem, I want to get rid of something to stop my problem, right? Let me say that in a different way. If I have a bug eating my plant, I need to kill the bug. If I have a weed in my garden, I need to kill the weeds. These are not, that is not the correct paradigm, because the more you kill weeds, the less your mineral cycle is going to work. The more you kill weeds, the less your energy flow is going to work. The more you kill weeds, the more it stimulates your microbes to do the wrong thing in the soil for the plant you're growing. And then the method you choose to kill your weed, that can do all kinds of weird things too. So what's the solution? Because that's our paradigm. If we have a problem, we've got to kill something or remove something from the environment. But my paradigm, and the paradigm of Alan Savory, and the paradigm of the ecologists who actually have real results in this whole discipline, is when you have a problem, you have to figure out what to add. So if I have a bug eating my stuff, what do I need to add? Is my mineral cycle working? Is my ecological community working? Or something's wrong with my community dynamics. In fact, that's the one big indicator. I'm glad you brought this up, because I probably should have concluded earlier in my short presentation that if you do have a problem in your food growing like environment, in your garden or your acreage, the first thing to look at is your community dynamics. You want to go out there and look at your succession, what's happening with succession. Don't look so much at your water cycle. Don't look so much at your energy flow. Don't look so much at your, what's the other one? Don't look so much at those, okay? Your mineral cycle, energy flow, and water cycle. Those are not the indicator that's going to give you an early idea of what's going to be happening to your farm in 5 years. Look at your community of what's growing and thriving and what's not there that should be there. Your community dynamics is going to tell you all kinds of things. That's how you predict your future. Your community dynamics is your crystal ball to see the future of your nutrient-dense food or your starvation food. What's it going to be in a decade from now? Is it getting better? Is it getting worse? But interestingly enough, you wouldn't go to try to fix your community dynamics if something's wrong. The first thing you want to fix and restore is your water cycle. So this can get complicated. But we have millions of American farm acres that are starting to do this. The Understanding Ag Group, they are consulting millions of North American acres, which is wonderful. The East, the Midwest, the West, the South, Canada, Mexico, it's working. And they have their monthly webinars. Why aren't people listening? Because it's a wicked problem. Because our mindset is, oh, if I have a problem, let's get rid of it. Let's not do that. Let's use a different mindset. Let's win people with love instead of assassinating or getting rid of people. Instead of genocide, let's convert the people. You know. I have no idea if that answered your question, but we understand the world by the glasses we wear. Everybody sees through the lens of their own paradigm. So we have these glasses on, and we are looking out there, and we could have 100 people looking at the same thing, and then they go home and write it up, and you have 100 completely different stories because you have 100 different worldviews, you have 100 different experiences, and until the masses of people have a community, there's probably a word for this, but the entire world, the whole community, the whole country, the whole culture needs to have a paradigm shift. There's a name for that. What is it, Vernie? I don't even know what it is, but you're the queen of words. But that societal shift in thinking has to happen for people to understand it. Alan Savory uses the brilliant analogy of people used to be burned at the stake. Galileo said the earth is round. We go around the sun. You can't say things like that if everybody thinks the earth is flat and the universe revolves around us. If the universe revolves around us and I come out and say, no, we revolve around the sun and the earth isn't flat, I get burned at the stake. You can't do that. You can't translate the Bible so that the common man can read it. You get burned at the stake. We get killed for things like that. Luckily, we live where we do today, and you simply just get exiled. I mean, Alan Savory himself, he was exiled from his native country. They kicked him out. He lives there now, so apparently I don't know, they have a lot of politics change. They're probably not even the same country anymore is what exiled him. I don't know the details, but the thing is, we have to see the world differently to actually implement this stuff. So why aren't people doing these things? Because they went to college and they paid tens of thousands of dollars to get their degree, and to do it this way, they would have to admit that their degree was worthless. And there are going to be people hear me say that, and I don't mean, education is wonderful and great, and I hope all of my kids embrace education way more than I did. So that's not what I'm saying at all. What I am saying is that we have to forgive the things we learned in the past. Let me say that in a different way. My brother-in-law went to medical school, and he had a brilliant teacher, and he said, our job is to tell you what we know is right. Your job as a medical doctor working with patients is to figure out what we taught you that is wrong. And that's what we have to do as agriculturists. We have to not do what we learned in college. We have to be asking the questions every day. Is this actually working? Because right now, farmers sell their food for a profit, to make money. That is the purpose of food, is to bring in an income. And the way that you do that is to create more bushels per acre every year. When I was a young person, 150 bushels to the acre was a great crop. Nowadays, with all of the science that has gone into creating 150 bushels of corn, nowadays they are getting close to 400 acres for corn. 300 acre bushel corn is becoming the normal goal to reach for. 200 bushels an acre is normal. If you're under 200 bushels an acre, you're doing something wrong. This is the prevailing mindset. But you're going to be having a monocrop. You're going to be using the major sciences. You're going to have GMO seeds. You're going to have the best in your agronomist is going to be out there. They're going to be looking at your soil. You're using maximum science to be able to do that. And that's the paradigm of how we grow food. And the purpose is to earn a profit per acre, per bushel. That's what we do. But that's not the right thing to do, because it's hurting those 4 ecological processes. It is desertifying the land to do that. And when people hear me say that, they normally are looking through a lens of politics, because it's all they hear. Unless you're involved in this whole thing and you hear me make a statement like that, you suddenly put me in the camp of the liberal left, because that is what all they have heard. Their only context for hearing things like this is politics. But see, there's a lot of ways of seeing this. We can see it from a political point of view, but we can also look at it from an agricultural point of view. We can look at it from a religious point of view. We can look at it from an ecological point of view. There's a lot of points of view to look at this from. So if we go back to the corn example, an ecological point of view is 300 plus bushels of corn a year is destroying the environment. We're not going to be able to continue to grow food that way into the next 200 years on the same land. And we don't really have any more land. So what are we going to do? Well, guess who loves to hear that and promote what I just said? It's the political point of view. Those guys grab that information from the ecologists and then they use it for their own agenda, except they don't have a solution. Their solution is the wrong stuff. YouTube is filled with all kinds of stupid videos that are saying, oh, we're going to run out of food. I don't really think we're going to run out of food, because there's enough people creating food in the right way from an ecological point of view, and they're using holistic management to do it. So, and that is growing. It is a growing thing. But why aren't more people listening? I mean, we have 4 people on this call tonight, including me. Why don't we have 4,000? Because it's not something in people's paradigms. We haven't had that societal shift yet. That's why. And we have so many different worldviews and so many ways of seeing things. You know, some of my very best friends in the world hear me talk, and I generally don't talk to them about this stuff, because when they hear me talk, their only context is a political point of view. And so if I say climate change, the only place they've ever heard that are from the fools who talk about fixing climate change, except they don't have a fix. They're just taking things away from people. They're taking away our freedoms. They're taking away morality. They're taking away all these things that we hold sacred. But that's the only context that they have to understand the word that comes out of my mouth, which is climate change. But see, I can change the climate any time of day. I go out here and I change climates in my microclimates all the time. It's brilliant. It's beautiful. It's wonderful. I can take desertifying land and turn it into a beautiful grassland that is sequestering carbon. Oh, carbon! And from that political point of view, you're a leftist. No, I'm not. I'm an ecologist. And carbon is one of the major points of the mineral cycle. And we need a lot of it in the air floating around, and we need a lot of it in the ground, because it's a mineral that the plants are using. The microbes need it. Without carbon in the ground, your microbes die. And then with dead microbes, there's no mineralization happening, and then plants die. Ecological point of view. So this was a very long answer to your question about why aren't more people doing this. It's because we have our views, our worldviews. A lot of people have a make a living point of view. Oh, I'm just going to work. You know, I'm going to go to work. I sit in my chair all day in my cubicle. I'm on my computer. I'm doing all these important things, and it provides a paycheck for my family, and I'm able to save some money for retirement, and that's my focus, and that's their point of view. And it's not a bad point of view. It could be a narrow-minded point of view if that's all they do. Hopefully people are a little bit more widespread than that. I'm not. I have a very narrow point of view. I'm the workhorse with blinders on, and all I see is my garden. That's it. All of this comes because I am so focused on the wrong stuff most of the time, which is my garden and ecology. Half the time I can't even pay my bills because I don't know they're due. My poor wife. So we need to expand. We need to have broad and deep educations to be able to understand what people are talking about. Okay, our time is up, And thank you for being on tonight. We're going to close this down. And if you know anybody who needs a career in farming, tell them about my 17-week course. Get them in contact with me. Spread the word. We are going to be starting that up next spring so that they can learn a career in agricultural production and how to be profitable, because we're not spending lots of money on fertilizers, fossil fuels, all of the big expenses that come from modern agriculture. We're going to do it in a different way. We're going to do it in a way that is healthy for the 4 ecological processes, which makes families healthy, which makes our educations beautiful, and we have plenty of leisure time to love our life. Good night, and thank you for being here. Next
Thank
week,
you.
next Thursday. Thank you, thank you, thank you.
Thank you.
Okay, I'm going to end this if I knew what button to push.